what's the first step to managing any asset? And it has to be located. So you've got a campus, you've got a building, you've got floors in that building. You want to find a floor, you want to get rooms, you want to find a room, and you want to find data in that room. That's the ideal that any owner wants. Likewise, you've got assets, you find a particular asset, and you want to find data in that asset. In an ideal world, you want to use a handheld device to find that. And ideally, you want to use a map. So in the broadest view, the intention here is we want to make models useful to do this right here. So, there's a mindset also that I want to make clear. Sometimes owners have this idea that they want to use BIM to manage their facility. That's an absolute mess. We've tried that multiple times, never wants to happen. Architects, engineers, and contractors create the Revit models. They're the experts of making the models. That's what they do best. The owners ideally should harvest that data. That's the key. In an ideal world, you want to be able to harvest the data and use it for all different types of departments within an institution, whether it's asset management, facility management, space management, indoor GIS, capital planning, doesn't matter. Whatever it is, ideally, all these departments should benefit. And that's always been our perspective, is try to encourage a spread and distribution of this data across these departments, because they can all benefit. So in a typical workflow, an owner hires an architect, the architects build these models, the contractor builds the building, and they build models too. And when the building is delivered, the models are then shelved typically. They don't use them because there's an inconsistent data structure. So the owner ends up having to spend 6 to 12 to 18 months recreating the data, somehow trying to figure out how are they going to manage and maintain the assets in the building. And this workflow we found is insufficient. And the reason is the architects and engineers and contractors aren't contractually required to provide data-rich BIMs. So instead, we've created a workflow we call Collectus, which allows a facility owner to benefit and empowers the facility owner to harvest the data into a digital twin, literally within hours of handover. So in this workflow, and we call this a business process model, with it as an example of benefiting from BIM. This is an example of it. We've created
and we call it a strategic asset management plan.
Absolutely. From an owner's perspective, it's the owner is leading the show here. That's the key, is that it's coming from the owner. So the owner provides to the teams, the AC teams, a BIM execution plan, but it includes data. And we're going to look at that in a minute. The architects start building their models. They're using this Collectus workflow. The architects or engineers are doing it. The contractors, and some contractors, as they build the building, they're building their models too, using the same Collectus structure. The owner has a mechanism of checking the models. We'll look at that in a minute, because that's one of the other problems that owners never have. And when the models are delivered and at handover, the building's done, the models are delivered, those models are data rich and then can be harvested literally within hours. And we've proven this multiple times into a digital twin like a NUMA system, where now using your handheld device, you can find the warranty information, you can locate the valve, you can locate the room and the information about the floor of that room, whatever it is, doesn't matter. The data is at hand within this digital twin. So here's an example of just that. Here's a data-rich Revit model. You can see all the parameters, the data structure that's there. You can see it here on, the warranty information, installation date. The information is already there. They just have to fill it in. And that gets harvested into a NUMA system. And from there, you get this digital twin, okay? Now, there are 3 steps to do this. The first is to define the requirements within a BIM execution plan. And with the case of Collectus, it includes data. And that includes industry standards like CSI and COBie, the Master Format, Uniform, and Anomaly class, inside the BIMX plan. So if a user was to open up Collectus, and by the way, this Collectus structure, the owner gets the subscription, and the entire data structure of Collectus is offered to any one of their architects, engineers, and contractors and subcontractors within Revit without cost. They can get access to all of the entire library, and you'll see that in a minute. The architect has the BIM execution plan. It's within Revit literally. And within this BIMX plan, we have required data requirements. We call it LODI, level of data information. There's LODI 300 for the architects and engineers to fill in this case for the air handling unit. LODI 400 for manufacturing information, again, contractor and subcontractor fill in, and LODI 500 operations and maintenance data for the contractor and subcontractor to fill in. These values that you see here are nothing new to the AEC team members. We're just defining it as a requirement in BIM for the teams before we begin. Next, the next step is the owner has to provide this data structure to the AEC team members so they can actually build models that have an LODI 300, 400, and 500 for the contractors and subcontractors. So within Collectus, there's an entire library of 36,000 components coming from all the work that we've done in the last 22 years with all these AEC firms that you saw earlier, you know, SOM, HOK, NBBJ, AECOM, Denver International Airport, all this experience that we have. So here, this entire library, metric and imperial, would be used to build the models within Collectus. We're dropping in doors, we're dropping in plumbing equipment and piping equipment, we're dropping in within the model mechanical equipment and ducting equipment with the structure, the data structure that's required. So here, this is a tower, an 18-story tower that we did with Onuma Systems, where we took this tower, built it in Collectus, and with MEP, and brought it in. You're gonna get in a moment, you're gonna be able to try it yourself. Step 3, the owner needs a mechanism to validate the model. And that's been the problem all along, is that owners don't have BIM experts. So we've created within Collectus a structure that allows the owner to check the models without being BIM experts. So here, if I look at the Collectus model, all of the requirements that were in the BIMX plan for data are built as Revit schedules. It's like an Excel file inside of Revit. So the team members can load in all the required LODI, electrical, mechanical, and plumbing schedules. They can load in the LODI 400 and 500 schedules for all the different asset types. So that when an owner, when the builder has a model, you can see the schedules exist already. They just have to fill the data in. And if I zoom out with the schedules, you see LOD 300 is smaller, LODI 400 is a little bit bigger, and LODI 500 is huge, but it has all the data in it. So instead of exporting to COBie, which is a snapshot in time, here the data stays live in the models, and the models are data rich. And if someone deletes an air handling unit, it disappears from the model. If someone adds it, it's instantly updated, or someone changes it, it's instantly updated. The model becomes the single source of truth through this process. And with that model, and by the way, these schedules are designed for the owner to check. So again, we spent about an hour and a half with the owners showing them how to open a model, how do I open a schedule, because you can use this schedule to check to make sure, have all the values been filled in? If they're not filled in, send it back to your team and have them fill it in. And thus,
A
there's a mechanism
workflow that actually serves the owner.
Exactly. There's a way, without being Revit experts, to check the models to make sure the data is filled in. And if someone deletes the model, the owner can load it back in. That's part of the training. We can load it back in from Collectus, and instantly it fills in. And so the entire intention here is that when it's done, it's harvested into a digital twin. That's the key, is that we want to be able to harvest this data literally and within hours to bring it into a digital twin, like a Onuma system. So the intention is we want to be able to find the campus, the building, the level, the room, and whatever asset information or room information or detailed information, we want that from our handheld device. So now if you want, you can use this QR code, take your phone, just scan that QR code if you feel like it, and you take a photograph, you can scan it, and when you do, it'll say BIM Storm. And what you'll do is it'll say go, you'll click the go button right there. And there you can choose, and you'll see actually the campus. This is the campus of where we're speaking next week at NIBS. There's a floor plan of it. It shows it shows all these various buildings. Literally, you're looking at almost like a campus of your facility right there. If you click on select a building and you choose Collectus Apartments, There you'll see the Collectus Tower that you saw a minute ago, that 18-story tower. If you choose level 5 as an example, and then if you click on a room, okay, there I've clicked a room on level 5, and if you scroll down, you can actually create a work order and submit it. So literally, as a CMMS application, you're looking at a CMMS application for creating work orders. It's quite remarkable, and we're using a map, and literally to create this model was hours of effort versus weeks, months, or years, or none at all, at the handover. And for those projects that have existing data, a NUMA system allows the consolidation of a variety of platforms, data platforms, to be brought into this single data. So we would always tell our clients, don't try to recreate Revit models from existing buildings. That's horribly inefficient. The better mindset is use what you have. If you've got CAD or PDF or JPEGs or PowerPoint, whatever they are, that can be brought into this digital twin also. It may not have all the information that a data-rich model would have, but it's a great start.